Liam, how are you today?
I'm good, thanks, Derek. Yourself?
I'm good. I'm good. I'd say it's sunny, but obviously with my accent, being Scottish, we know that that only happens 3 times a year. But no, I'm good. I'm good. I'm good. So, tell us a little bit about yourself.
So, as you know, my name is Liam Gulliver. I am a DevOps consultant and systems team delivery manager with MMT Digital. And I also do a lot of community activities because I can't help myself largely. So I'm one of the co-organizers for a DevOps meetup down in the Midlands called DevOps Nuts. I also am one of the co-hosts of the Agile Engineering podcast, which is available on pretty much every platform you get podcasts on, where we talk about DevOps, cloud, um, SRE, Agile, software engineering in general, kind of a bit of everything. And a week tomorrow, also having a go at taking a leaf out of your book, Derek, and trying to do a live show on Tuesday, every other Tuesday lunchtime, called Azurish, where me and my other hosts, Pete Gallagher and Jonathan Ralph, will be effectively trying to build something from scratch in like a scrap heap challenge kind of way with the Microsoft stack every other week. What it's likely to be is about an hour of three middle-aged men Googling things, but live. So
Yeah, that sounds about accurate. No, that sounds
yeah,
really cool. So, just a shout out, obviously, if you are on Twitch, is that twitch.tv/Azurish Live?
that's it. Yep.
Awesome. Obviously, follow Liam, Pete, etc. On Twitch. So, what are we going to be talking about today?
So I thought it'd be good for us to start talking about something that I don't think happens enough. Something that I've definitely experienced with working with the broad range of clients that I do, and that is container vulnerability scanning. So plenty of people vulnerability scan their code with things like Veracode and even SonarQube and that kind of thing, but the container images themselves usually get forgotten about. I'm a big fan of Azure DevOps and GitHub, and I figured what I would do this evening is take you through how to do that with a tool called Trivy, and we'll go and build a Docker container in Azure DevOps, scan it, fail the build if anything goes awry, which are likely, let's be honest. And then if it's all successful, we'll push that out to Docker Hub.
Awesome, awesome. It's funny. Container security. I did a webinar back probably about 6 months ago now for Octopus. It was based on security, and it was funny. Like, obviously, security is something that we take very seriously, as
Mhm.
everyone does. Or well, hopefully, or they definitely should take it seriously. But one of the things that honestly, I remember looking at container security, and it felt like it was barely a thing. Like that security, like see, like SonarCube. SonarCube's been about for what, 10, 12 years. Um,
Possibly longer than that. Yeah, it
yeah,
feels like it's been along in the industry as long as I have.
yeah. Well, that's it. Like I remember, obviously you would integrate it with like a build server, and then obviously you would get your report. Most of it was stuff that you could ignore, but at the same time, um, containers obviously are still fairly new. They're obviously generally available, but they're still not like massively used.
Mm.
So yeah, I'm really looking and I'm looking forward to this.
I think that some of the cause of that is sort of two things. One, a lot of security tools are notorious for being ridiculously expensive.
Yeah.
So a lot of companies sort of, unless there's a definite requirement from like a compliance point of view or anything like that, they won't necessarily invest there, which does understandably come and bite them in the arse at some point down the line. Or there's been this myth, and I've been a victim of this myth in the past. Is like there was a big thing around, well, containers are secure by default, and that's just not true.
No,
for a whole host of reasons. And at the end of the day, you're still running a piece of kernel. If you're running a bit of Ubuntu or even Windows Server, they're still susceptible to the same issues, patches, and zero-day attacks and that kind of thing, just as a full-fat client would be.
Yeah, it's not. I mean, it's probably not got the full surface vectors of attack, but it's still got quite a lot of them.
For sure, yeah. I mean, once somebody's in,
yeah, that's it. It's so yeah. Let's jump in and let's have a look.
Okay, so what I figured I'd start with, I'm going to just sort of doodle out what it is we're gonna do. So hopefully this should work. So we're going to start with a terribly drawn box. There we go. That's fine. So what I want is when I push a commit back, I want that to go off and trigger a build in Azure DevOps. And from there, once that container has built, I'm not going to write any unit tests today or write any code or use some pre-made. Here's what I made earlier, Blue Peter style stuff. But I want Trivy to then do a scan of the container. And that's going to look for vulnerabilities in the base images. It will check against, I can't remember what they're called now. Mine's gone blank, like the CVEs and that kind of thing. And if it's all okay, we're going to stop the build. And if it's good, sorry, if it's not okay, we're going to stop the build. If it's good, then we're going to push it to Docker Hub, or that could be, say, an Azure Container Registry or an Elastic Container Registry if you're a fan of AWS. And then we are done at that point. But what we'll do is we're going to build this up bit by bit. So I've got a blog post with all of this information in already. If you go to lgulliver.github.io, this is already all on there. And there's GitHub Actions flavors as well. And I'll touch on some of that this evening as well. So that's roughly what we're going to do. As part of this, I'm also going to use GitHub Codespaces to make some of these changes as well. So let me just switch to a different window. So what we've got here is this is Trivy itself. It's open source. It's available on GitHub. It's completely free, and that's one of the reasons that I really like it. You've got other options as well, like Anchor, which is also pretty good. But this is the one I've had the most success with. This is the one I've had the most success in terms of accuracy with as well, and it's pretty goddamn quick. Because that's another thing I think that holds people back from going down this route is you say, okay, we need to do security scans, and they can take a while depending on the tool set and how much you want to cover. And people are reluctant to add that extra sort of maybe 5 or 10 minutes or even longer sometimes into their builds. Whereas this literally takes seconds. So what we've got, if I just scroll down, is it can be used as a command line as well, and it's really straightforward to use. Like I say, it's written in Go, and all you have to do is run the true command, point it at what image you want to use, and you'll start to get some outputs that look a bit like this in terms of results into the console. That's all well and good if you're running it locally, and in some build tools, that's fine, but you've got to go and do some digging to see that. So what we're actually going to do as part of ours is we're going to output that into a test file for in a format that Azure DevOps supports. And with that, we'll tell Azure DevOps whether we want to succeed or fail the build with that output. So in terms of Azure DevOps, I don't know how much people know about it, but it is a CI/CD tool from Microsoft. Oh no, it's just taking me to it. And what we can do here is we can use source control, we can do our builds as YAML, we can do our releases, we can hook it up to Azure, AWS, Google Cloud. It's really a whole end-to-end solution to help you get what you build out into end users' hands. And it doesn't have to be stuck to Microsoft technology either, which is great. I've gone down that route just because it's nice and easy. And the Docker container I've built, or the Docker project I've created, I actually did with Visual Studio with a Docker file, and I enabled the Docker support in the solution. So what we've got here is our source project. This is available in GitHub, just here at this Gulliver /container scanning. And in there, we've got everything you need to be able to do this at home, if you will, along with links to all the blog posts as well. So what we're going to do is we're actually going to use Azure DevOps to do the builds, but all the repository we're going to pull from GitHub. And Azure DevOps will also do the scans with Trivia as well. So let's start by actually just building a Docker container. So I'm going to just create a new file. So what's actually going to go into this Docker container is all of this here. So this is, or the output of this, should I say. So this is just a straightforward ASP.NET Core MVC site. There's nothing special going on. It's literally just a view with an index page. It's not doing anything. This is just as it comes out of the box when you create a new project. But what I'm going to do is I'm going to create a new YAML file, and we're going to call it Azure Pipelines build push Docker. YAML. You can actually go and you can actually do this in Azure DevOps if you wanted to, but I'm going to do this in here, partly because it's a little bit quicker, and I want to just stick it all with my code anyway. So what I'm going to do is I'm going to tell it that I want what branch I want it to trigger from straight away. I haven't renamed my branches yet on this repository, but I will do. So it's currently called master still.
Liam, could you just zoom in just a little, just a nudge? It's a little bit hard to see.
Oh, that's the wrong button.
I have to say I like code spaces. I thought that was honestly I honestly thought that was VS Code.
Yeah, I mean it's great. I've done some slightly more advanced things in it as well. So I've been filling around with working out how to build a command line tool in Go, and I've been doing it in all in code spaces. And I've not had to touch anything on my machine once, and it's been great. I've also done some Azure function stuff with code spaces and run it, and been able to connect to it with Postman from my local machine to see what's going on with it, and send it test data and that kind of stuff as well.
Yeah, it's really nice.
In fact, when we do Azure-ish, we're actually going to use a lot of code spaces as well, and put all the code as we work through the project straight into public GitHub, so people can actually go and contribute to it live on the show as well if they want to, and be able to pull that into code spaces and all sorts.
Nice, I love it. I love it.
So we'll just need to tell it what resources we're going to use. We're just going to use this repository at the moment, so that's going to be repo self. I want to give it a couple of things I'm going to use all the time. So we need to name the container, and we need to give it a tag, as I'm sure everybody knows. But let's give it a tag. And what I want to do is I'm going to use the actual build number and where it's come from for each tag. So we can just use our Azure DevOps build variables here. I'm not doing anything special with the build number. That's the wrong kind of tick there, isn't it? I'm not doing anything special with the build number. We're just going to use the default out of this. In fact, what we should do is docker.com. If we do, what is it? So we already have our container scanning demo here. And here's one I did earlier just as a test. And you can see that's the sort of format we're expecting out. That kind of thing. So rather than me bore everybody to tears by typing this all out, I actually have, here's one that I made earlier, where I've got my variables where I am putting my tag in. I've got my image name. So when it goes to Docker Hub, that's what it's going to be tagged with. Sorry, that's going to be the image name, and then that's what it's going to be tagged with. So like we saw here, it is under liamgoo/container-scanning-demo. And then if I wanted to pull that down, I can run Docker pull Azure DevOps. I'm not going to do that right now. But what I will do is sort of take you through what we're doing here. So we've set up a couple of, or we've set up something called stages. This is actually going to be only a single stage build. You can have multiple stages in YAML. So you could do the build, and then you could actually do a stage that says, I'm going to deploy to my dev environment or my QA or pre-prod or production. But I've just got the one stage that I'm just going to build the container right now, and then I'm going to push it straight out to Docker Hub. So we've got stage, we've got the jobs that we want the stage to do. So we've got the build. That should just say build. We've got what image pool that we want to use. So this is what kind of build agents we want to use to build the Docker image or your code or whatever you're building in Azure DevOps. You've got a few options. You've got a couple of flavors of Windows ones. You've got ones that are running the latest Windows Server with Visual Studio 2019. You've got some old, I can't remember what the old one's called, but I think it goes back as far as Visual Studio 2017. You've got a bunch of Linux agents which all run Ubuntu. And you've got a bunch of Mac agents, which I'm sure somebody could correct me if I'm wrong, but there used to be a bunch of Mac minis in a rack in an Azure data center somewhere, whereas everything else runs as Docker agents. So we've got fresh, brand new agents each time. That when we use the Microsoft hosted ones, they're completely disposable. They're spun up fresh every time you request a build. And the great thing for open source projects is that you get a bunch of them for free, and I think you get unlimited build minutes with them as well, and you get 10 of them to be able to use completely free. No, sorry, it's not 10. I think it's less than that now, but you can do a bunch in parallel. Is kind of what I'm getting at there. So now we're going into steps. And this is the sort of task that we want to use. So if I was using the Azure DevOps UI to do this, you would see a bunch of tasks on the right-hand side. And we'll do that in just a second. I'll show you this file inside of Azure DevOps. But we've got a task for Docker. The at2 is the version of the task that we're going to use. And that's something that Azure DevOps will already interpret. And what inputs are we going to use? So I've got a container registry set up. Or a container registry service connection setup, should I say, that just goes to Docker Hub. You need to set up a service connection in Azure DevOps to actually tell it where it needs to go, and you need to authenticate to Docker Hub, as I'm sure everybody knows, to push an image up to it. So we've got where we're going. We've got the repository, which is our image name. So that will be that liumgu/container-scanning-demo. We've got what Docker command we want to use and what Docker file we're going to use. I've only got one Docker file in this, so it's just going to find the nearest Docker file, and it will do the first one it comes to, and it will use that. I've set my build context. So this is the folder I'm building in, which is this source directory here, and then what tags I'm going to apply to it. And this turns into your equivalent Docker build .-t, and then the whole image name. And then as soon as that's successful, we're just going to push that straight out to Docker Hub. So I've added that. I'm not committing it back yet. I've saved it. What I will do is I'll just open up a terminal, and let's go back. Oh, if this was the real world, I wouldn't just be doing this straight back to master. So don't try this at home.
What do you mean? You don't just commit everything to master?
I don't generally. Even when generally when I'm working on my own stuff, I even try and follow. Let me do a branch. I won't PR it, but I'll look after my own stuff in its own branch before I merge it in. So that's now been pushed back. So if I go back into here, you'll see there is build push Docker. That will already have kicked off some builds in Azure DevOps for me because I already have triggers going. So if I refresh this page, you'll see that all of these have just triggered, but we'll come back to these in just a second because we're actually going to add in a new pipeline. And like I say, I could have done all of this in the Azure DevOps UI, but I don't tend to. That's just me. It's entirely that's I know you don't, Alexa, but thank you. So, but you can do it all in here as well. But because I'm using GitHub, for some reason, I've managed to teach myself to just do it in GitHub first and then into Azure DevOps. But you don't have to do it that way, as you'll see in a second. So I'm going to tell my pipeline where my YAML is, which is GitHub. Give it a moment. And it will give me my vast list of GitHub repos. So you want container scanning. And you see, these are pre-made images. Sorry, not pre-made definitions. As I've already built one, I'm going to use an existing Azure pipeline YAML file. And we're just going to point to the right one. So we've got this build push Docker here. If I open that up, there you go. We can now see it in here. You also get a bunch of linting and other sorts in Azure DevOps. And really, as I say this, I think I've convinced myself that I should have just done this in Azure DevOps in the first place. If you got Show Assistant as well, you can also add in all your tasks and stuff, or you can click on settings for a given task and change it in here instead if you wanted to. And it makes it really easy to use. Even if you don't want to go down the code first route, you can actually go through in a similar manner to how the old GUI editor used to be. So I've got everything that I want in here already. I'm going to save this and create the pipeline. I don't necessarily want it to run right now, but I am just saving it because it just names it after the repo, which isn't great. So I'm going to go and rename that. You can call that build and push Docker. So let's save that and then run the pipeline. Now this, in theory, it should work because I tested it right before we went live, or it could not. Right. Okay. So what I've done is let me edit in here. So your stage names can't have spaces in. Not sure why, but it is a limitation. So let's just save that and give that another run. So it will go through and validate it when you try to run it. And evidently I got it wrong. But now we have this build running. We are queued up. And that should also run in a second. So it's actually going to run through all of these. So let's just quickly cancel these runs. Because we don't want to wait for all of these. Oh, no, wrong way. Okay, so let's just cancel all of those and just rerun this pipeline because I managed to cancel all of those as well. So this should run. It can get added to a queue, you know, if there's a bunch of jobs waiting, as you'll have seen a second ago. But what we've got here is the job now actually starting. So it's going to go through each thing. It's going to check out the repository. And as you can see, we're now building our Docker file. So let's just, whilst that's running, let's take a look at what the Docker file is doing. So it's super simple. Because, no, I don't want to. Thank you though. This is just the pretty much out of the box Docker file that you get when you enable Docker support on a .NET project in Visual Studio. The only changes I've made here is just changing my work directory and where I'm pulling the images, sorry, not the images, the files from, because I restructured my project. But what we have is we have our base image, which is just the ASP.NET Core 3.1 runtime. We're exposing, we're telling it what directory we're going to work out of, what ports we're exposing, so 18443, because this is going to be a web project. And then what we have is we're actually pulling down a second image as part of the same Docker file. We're pulling in the .NET Core SDK 3.1, changing our work directory to our source directory, copying the project and everything that we need to build it, doing a NuGet package restore, copying our outputs into the right directory. We're also then going to change what directory we want to run our build command from, and we've then gone and done that. We've changed that, we have that build command output everything to /app/build, and we have an intermediate layer where we take what's just been built and we actually publish it. So it's all packaged up, nice to go, nice and ready to go. Then we refer back to our base image up here and call it final, and copy what we've just put in this publish location from, you know, we're taking it from this publish layer, taking it out of this folder, and then putting it in the root into app in this final image. And then we've got the entry point, which is the DLL, so that when the container starts up, it'll start Kestrel and you'll start seeing everything that you need in there. So with any luck, I should have just talked for long enough that this is completed successfully. And we have our build. So you can see that it's gone through each layer here. We've gone through every step. We've pulled down the .NET Core runtime. If there is a version cached on the build agent, so even though these agents are disposable, there's still a cache of build images that are available to them to speed up builds as well. Not everything is, but some of it is. I can't remember what ones exactly, but it does help to speed up on these runtimes. So now you can see as we're running through each command, So there you go. There's that 443. And that's the last step of that first layer. Then we've got our SDK pull down. So we're doing that. And we've got that whole build that runs there. So now you can see that we've gotten down to the .NET build. There's your standard build output that you would expect, as well as our publish. And then we've tagged it all in there. So that's the image tag in its entirety. So that should have run now. And if I go to Docker Hub and refresh this page, we've got a build of 2020 10 19.3. So we should have an image in there with that tag. There we go. So that's already our Docker image built from Azure DevOps. And that, most of the time, other than a couple of differences where we've got people running unit tests, as you would normally, that's pretty much the end-to-end flow for a lot of people, which is fine to a point, but I don't actually know what is in those containers without, other than my application. Now, without me going in and interrogating each container image that we've used individually, or building my own from scratch, I don't know what could be in there 100% of the time, and I don't know how up to date or ultimately how vulnerable it is. So let's add in our image scanning. So let's actually start with a step back. So let's scan a pre-existing container. So I've already got this this build set up, and we're actually just going to go and for the sake of the demo, we're going to scan the actual ASP.NET Core 3.1 runtime. In fact, let's use the same tag. So it's it was Buster, I believe. Save that.
Was it Buster Slim by any chance?
Yes, it may very well have been. Let me double check. Yeah, it was. Well spotted. Just testing, paying attention. Okay, so let's do a new terminal. The important thing to note is that there is a newer version of Trivia out, but I haven't toyed with it enough yet. But yeah, we're down 0.1 to 0.0, I think, which came out about a week ago. Oh yes. Of course. Right, tell you what, let's not worry too much about that at the moment. Let me come back to this in a minute because I didn't pull. I don't think so. Git reset dash hard, doesn't it, to go back to undo the last commit?
Yep, it should be, yeah.
There we go.
There we go.
So we've got in fact, let's be a bit cleverer about this. So I can ignore the fact that I have just forgotten to pull that out. Just create a brand new code space, which is the other great thing about code spaces is if you cock it up like I just did, you can just start again very easily. So whilst that is initializing, I can show you what we've got in here. So there's our successful build, and these are the ones that we cancelled previously. and we're about to run this one. So we should have our code space ready. Okay. So here's our. So I don't need to. I don't need to put down what I did before because it's already latest because I recreated the code space. So that'll push back and trigger all the builds. So it might take a moment, but Azure DevOps is already listening out for those commits back.
I won't lie, whilst you were doing that, I did just go and sign up for the GitHub Code Spaces beta.
It is good. It is pretty good. There's some really cool stuff you can. It's incredible. They like I'm only really scratching the surface with it, but you can also configure it in your repo for everything that you need for a dev environment for that repo with a dot file as well, and say, okay, well, actually, I need .NET Core, I need Azure Functions, and I need Docker or at specific versions or whatever else, and you can. Before you even create your code space, you can tell the repo that you need all of that. And when you create your code space, it will go away and get all of that as well. Same with, I think you can tell it what Azure, not Azure DevOps, what Visual Studio Code extensions you want pre-installed as well.
Oh, that's nice. We've got Michael Levan. He's developer relations, and he signed up for it and he's been going on about it. And I'm like, yeah, okay, Michael, calm down.
It's great.
But yeah, like looking at it, I'm like, oh, wait a minute. So yeah, I've just signed up for that.
And I think you get two that you can use, and in the beta, I don't know what they're going to charge for or anything like that, or how many more you'll get when it goes generally available. But I mean, they're so disposable; you don't have to store anything in them. You've seen now that I've bin mine off and recreated it within a couple of minutes, if that. And it's all good.
Yeah, no, I really like it. I think because the thing is, obviously, Azure, there's the code spaces of Azure where you can go in and you can use VS Code, Visual Studio, and it is now getting to that point where it's funny. I use Chocolate a lot for installing my software, but the thing is, it's getting to that point where you don't even need to install software. You can just, as long as you've got a browser, you can go.
Yeah, pretty much. I've been considering, depending what happens with the code spaces when it goes public, is getting a smaller, lighter laptop. So, like a Chromebook or something, or even doing it from my tablet and seeing how that goes.
Yeah, well, that's it. I think like that. One of the guys I was speaking to, he's using it on a tablet so that he can sit and code on his tablet at night whilst he's sitting watching Netflix with the wife. So he's getting the best of being able to code and learn, but also getting to spend time with the wife and watch a bit of Netflix as well. So, hey,
yeah,
if it wins.
So those have run. In fact, that's run a couple of builds at the same time that we're expecting to be triggered. So we have this existing container one that I created earlier. You can see that I've already run builds from it previously. And we've got this update tag that we've run here. It has failed, which is exactly what we're expecting it to do. Now, the reason we're expecting it to do that is as part of running Trivy, what I'm doing is on the agent is I'm telling it, okay, well, go and install this version of Trivy, which is 0.9.2.
Can I just
installs
it a little bit?
Yeah, sorry. I forgot we've changed the window since then.
That's much nicer.
Is that okay?
No, that's great. Thank you.
So we've got our install of it. We're just pulling down that release from GitHub itself. We're doing a D package, and then all we're doing is checking what version of Trivy we've got, with Trivia-V. If I go into Azure DevOps here, and you'll be able to see that has run. So we've got download and install Trivia. So it's gone and pulled all of that down. And if I scroll way down to the bottom, the last thing that's run is, there you go, we can confirm it's there because the version's there. So then what we're doing, because there isn't a native Azure DevOps extension for Trivia, we're doing it this way. We're installing the tool onto the build agent, and then we're running the scan from the tool that we've just installed. And we have to do that with command line. It'd be great if there was a task for Azure DevOps where you could just do this. And there is one for GitHub Actions that also includes Docker. But I've gone down this route to keep it simple for now, without the extension being available in Azure DevOps. So what I'm doing is I'm actually running it twice, sort of. So, and there's a reason for that. And I want to run it twice because for low and medium severity issues, I kind of want the build to pass. There's something to address for me for this project, but I'm not that bothered about stopping the release from going out for those things. For high and critical stuff that I really should deal with right now, though, absolutely do. So the way we do that is we actually tell it what exit code we want to have on those runs. So you have the exit code of 0 for this, to make sure that it fails. To make sure that it succeeds. And then, with high and critical, we've got an exit code of 1. So we've actually set the exit code regardless of what the outcome is, if I remember rightly, so that we can go and see what the high and critical is. Now, that's obviously not great for actually getting stuff out the door, because it will always fail. But for the purpose of this demo, we've got this running. We have the error here that we can see, and you can actually see out of that we've got our results, kind of like I was showing you earlier, but we have to go into the build logs to see them. So we've got 88 low and 9 medium from our low medium scan. Okay, and I just want to point out at this point that this whole scan took 3 seconds.
That's insane.
Scanning is ridiculously fast.
Yeah, like it normally takes hours, not seconds.
Yeah, and this is a whole Docker image. This has also got our application. Well, sorry, it doesn't have our application in it right now, but it is our base image for that. The whole runtime for ASP.NET Core 3.1. So let's scroll a bit further down. So we should have some high and critical. Yeah, so we've got 17 high, but no critical. Yeah, and it's telling us where it is, what the install version is, and what version it's fixed in, if available. You can do that with all sorts. There's a good demo of a Ruby one where they've done that as well. But looking at this, it doesn't actually look like that most of these are fixed in any versions according to this output. But it tells you what the actual issue is as well. So, we've got this derecursive in the regular expression engine. We've got the glob implementation that could cause CPU and memory consumption due to something, but the box isn't big enough for me to read. And that's great. So we've scanned that, but we could take that a step further. We can actually go and put that with our code. So we have our code here, and that now, this particular one, which we'll run in just a second, is pretty much just a merge of the two YAML files we've already been looking at. So we have this where we build our Docker image, and then we push it, and then we've got our, no, that's building Trivia itself. And then we've got this scanning of a pre-existing container. But that's all well and good, but we want to actually scan the container we've just built in the same pipeline. So what we're doing as part of this merge is doing our build like we were before, doing our installation of Trivia, but then our change here is to say, okay, use the image name and tag that we set up here previously. Ooh. So that'll look for the image locally first before it tries to go out to somewhere like Docker Hub or anything like that. So I'll actually just use the one that has just been built. And again, if that doesn't error out, it'll push the image out to Docker. So I'm not going to run this, but I will show you one that I did earlier. And again, this whole build with the scan. So this is building the image as well. So it's lightning quick, and then doing the scan. Now it hasn't pushed the Docker in this instance because it's not meant to, because that's what we've told it not to do. But building the Docker image with building our code inside it within a minute, albeit it's simple code, that whole scan still only took 4 seconds. We can still see that we've got our errors. And we've got those 17 high, and it should read roughly the same as it was before with 88 low and 9 medium. But that's now running that against that image that we have just built.
Got to say, this is really cool. I like the fact how quick it is. I mean, 4 settings. How can you even?
That's why I really like Trivy.
It's like 4 seconds is kind of what you would do to get started. Start your scanner. So no, that's really cool.
Yeah, I mean, if we want to be really pedantic, it's taking us 6 seconds to download and install it, and then scan it. But even then, your versus other tools, that's a fraction of the time that it takes to run this sort of thing. And yeah, okay, we aren't scanning our code. We would have to have another step that did that, but we are looking at the Docker image, and you can actually use Trivy to scan file systems as well and do all the stuff. But we're keeping it super light and super simple here. So this is great, but me as a developer or engineer or whatever, it's a real pain for me to get in and look at this output. It's fine, but I've got to do so much digging to get this output. Now, for me, I like Azure DevOps to be our one source of truth. And be able to say, okay, let me raise a work item to go and fix CVE 2019-18276. I can go do that quite happily right now. I could go and pick this, I could go copy it, and I could copy it out and go and create a new work item and all that sort of stuff. But I wouldn't be able to necessarily tie it back to a build very easily without going in and saying, okay, well, let me find the build and create a work item against that and so on. And that's, frankly, a pain in the arse. Nobody's got time to do that these days. So what we can do is we can actually output these results out to a format that Azure DevOps can interpret and import that into the test results. So if I go into here and I go back into the build, we have this test and coverage thing. So right now, nothing in there. We can see that the build has failed, and that's great, but that's not very useful to anyone. What I can do though is I can actually format it all out as JUnit. So what I've got is this little templates folder here with a JUnit template file. Now, this does get included with Trivy, but I couldn't get Azure DevOps to pick up the included version, so I have literally just put a copy of it in my repo, and I can then manipulate it or do whatever I need to from there. And we can all see that template and manage it from there. And Trivy can look at it as well. So what I've got, so what this is doing is it's actually going to take. It's going to be interpreted by Trivy, and it's it's in interpreter, and it's going to put it out to this JUnit format. And all we're doing to do that is, so you'll see that I've made a couple of changes here. Is I've taken out the exit codes because I don't want it to exit at this point. I've told it what output I want it to be. Also, I want it to be I want it to use a template. I want to use this template, and I'm going to call my file JUnit report low med, and then high crit.
Nice.
And then what I've got is these published test results steps. And the published test results steps will actually then take those, it will look for those files, and it will publish them into Azure DevOps itself. So you can then go through and see all those things. And regardless of what happens prior to this, I always want these steps to run. So if these files get created, if we get as far as these files getting created, I'd want these steps to just happen, so we can capture those failures at any time. What I also have is a set to say, do I want this to fail the whole task when it detects failed tests? Again, for low and medium, I've said no. And for high and critical, I've said yes. So what I've got is another pipeline set up with that called imaginatively Trivian JUnit. And you can see, we've got a load of failures here, which is correct because we have this ASP.NET Core 3.1 Buster Slim base image that we've already been scanning. We know we've got a set of vulnerabilities in there. And unless Microsoft have fixed them all in the last 15 minutes, we should still have a bunch of those failures. So let's go into this. So now you can see we've got this 0% passed thing here. Everything else, pretty much the same. We aren't getting as far as publishing it to Docker because we have failing test results. And I could, you can name these better. You can name them more accurately as to what they're doing. Again, Trivi, ridiculously quick. You don't get the output now because it's outputting it into a template. So you're not getting that output into the console. But if I come back, I click into here, what I now have is a full set of all the failing vulnerabilities that we've got throughout. So I've run a few tests today just to make sure this is what running for the demo. And these are new vulnerabilities that Azure DevOps knows about since the last 5 hours. So when this gets fixed, we'll also see, or I'd run it again, you'd also see when it got fixed as well. You'd be able to see how long, what version it was first failing in, what version we fixed it in as well. And I can expand each of these. So let's just expand that further, and you'll get the full information. Yes, okay, it's going against stack trace. So it's not perfect, but it is telling us that this is what the actual issue is.
It's so much clearer than what you were looking at earlier on with the output from Trivi. This is so much cleaner.
Oh, absolutely. And what I can do as part of this is now raise a bug against it straight away.
Oh.
So if I create a bug, it gives me all of that information from the off.
I have to say that's pretty beautiful, Liam. I'm very much impressed. I like the fact, because that's the thing, like raising. It's funny because it's like, I use Azure DevOps quite a lot. I think I've created about 4 tickets. It's a bugbear of mine, to be honest. But yeah, that's probably a bad reflection on me. But anyway, no, honestly, that is really smooth. I love the fact that you've created that, because it's true what you say. And not only is it hard to find, it might be impossible to find, because obviously, at some point those go away. Whereas if you've created it, you've got that artifact, then it'll never go away.
Well, exactly. And I think the other thing is, if you're just putting it out to console, it's very easy to miss a line in quite a long build log.
Yeah.
I was looking at something for someone the other day, in a Maven build, and all right, my background's primarily .NET, and it's been a long time since I've looked at Maven builds, but I missed something that a couple of other people had spotted. But the build log was 70,000 lines long. It wasn't output. It was a unit test failure ultimately, and it wasn't being outputted into Azure DevOps in this manner. And that's how easy it is to miss something, right?
Well, that's it. Because builds, it's like it's verbose you know, the amount of warnings you get that you can basically ignore as well. You do kind of become a little bit immune to it. Whereas this is not something you can become immune to.
And the great thing about a lot of this stuff is the syntax isn't too dissimilar to GitHub Actions. So if you do something in a GitHub Action, you can probably do it in Azure DevOps Pipelines YAML without many changes. In fact, I know we're probably running slightly over, but I will just quickly show you the difference with the GitHub Actions flavor. So we've got build, scan, and push with a GitHub action. We're very similar to saying where are we getting what action are we using? So this is build, scan, and push. Oh, sorry, this is build and push from Docker. We're doing the same as before. We're saying, okay, what repository are we using? So we're using Docker Hub in this instance. What tag do we want to use? The source, the source path for the build context, where the Docker file is, whether I'm not pushing. And then there's actually a GitHub action for Trivia in this instance. So we're using that here. I'm pretty sure there's a newer version of that now, but again, the same kind of thing. So GitHub doesn't have the same sort of output functionality as Azure DevOps does with the tests, or at least not that I've seen, and that might be coming. I'm not sure. If somebody at GitHub would like to let us know, that'd be great, because then I can update this. But we're basically doing the same as we were before. We're doing the scan and we're failing it with exit code 1 when we get to high and critical. But it's pretty much exactly the same output. So if I go back to github.com, container scanning, I get into my actions, we've got our build, scan, and push. And you can see, there's the same output as previously.
Very smooth, very nice. I like it. And that's it. GitHub Actions does seem like the long-term place to be for build as well. So yeah. Right. Well, unfortunately, Liam, we have came to the end of today's session. Unless there's anything else that you wish to share.
No. I think that's everything. Just as a reminder, you can get all of the source code for this and have a look yourselves by going to github.com/lgulliver/container scanning, and everything you need and all the resources and links to everything are all in that repo.
Awesome. Well, I just want to say first and foremost, thank you, Liam. I learned a bunch, never mind who else. So that's always cool. So just kind of want to say thanks. That was awesome. Trivia is definitely something I'm going to have a look at and have a bit of a play around. So definitely thanks for sharing that. Just one thing to be aware for everybody: if you want to follow Liam, he's available at LR Gulliver on Twitter as well.
Yes.
With that as well, you also have Azurish Live. So that's Azurish Live on Twitter as well.
Yep.
And it's also the same on Twitch as well, isn't it?
It is, yeah.
Excellent. So
in fact, we are also running a competition at the moment for Azure Live, although we've not done our first show yet. But we have these fantastic t-shirts, which turned out better than I imagined they would. Where, if you go and follow the Twitter account, follow us on Twitch and then retweet the tweet, you could win one of these on our first show on the 27th.
Awesome. Yeah. So this is on Twitch. Actually, I think I followed you because I won't lie, I've already done my retweet and I've done my like, so I'm also in the running for one of those sweet t-shirts. Free t-shirts are my favorite type of t-shirt. So yeah, obviously check that out.
What have we been doing without all of these conferences this year?
Do you know, honestly, it's funny. It's a lot of my I have like a tiered system when it comes to my conference t-shirts. It's like what I keep and then what the wife gets. See the one that you get when you go in the conference, and it tends to be cheap, it tends to be thin. The wife gets them, and then I get all the good ones. Saying that, obviously working at Octopus, I must have something like 12 Octopus t-shirts.
I was gonna say, yeah.
Yeah, it's like, so it's funny though. But I'm definitely up for don't rule me out of the competition. I'll definitely be there next Tuesday at 12:30 watching Azurish live on Twitch.
Fantastic.
Well, Liam, I'm going to wrap up now. So honestly, thank you so much for coming. It was great. I am going to check out Trivy. There's a bunch of stuff there. But honestly, if you do, just reach out to Liam on Twitter, Twitch. So many different ways to get Liam. So obviously, from that, thank you very much, everybody. And until next week, I'm back next week with Mert Yitter. We're going to be talking about traffic. So thank you very much. All the best.
Cheers, guys. Bye.